Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if using that self-driving mode in your car actually makes you pay less attention to the road? Well, this new study might have a clue. Today we're diving into a fascinating study that asks a super important question: how does our brain handle driving when the car does some of the work, especially when our minds are also busy with other things? Think about it like this: when the car is driving itself, do you get a break, or does your brain just find something else to do, and maybe not something good? That is the core puzzle our researchers wanted to solve. We know that when you are driving manually, your brain is working overtime, constantly scanning, thinking, and reacting. But what happens when a car handles the steering and speed control, known as partially automated driving or PAD? And crucially, what happens when you are also trying to do something else that is mentally demanding? Like a difficult conversation or even a brain teaser, but your eyes are still technically on the road. This is what they call cognitive load. So how did they figure this out? They got 41 people who were regular drivers and put them in a sophisticated driving simulator. This wasn't just a video game, it had a big screen for the road ahead, screens for mirrors, and importantly, an eye tracker. This little gadget watched exactly where everyone was looking. They tested 4 scenarios. First, normal manual driving with no extra mental task. Second, manual driving while also doing a two-back task to make their brains work harder. Third, driving with the partially automated system engaged, but with no extra mental task. And fourth, driving with the PAD system on while also struggling with that same two-back task. The two-back task is like a memory game where you have to remember a sequence of numbers and say what the number was 2 steps back. It is mentally taxing without taking your eyes off the road, which is why it is a good way to create cognitive load. The driving scenario itself was an urban environment, which is great because urban driving is full of distractions and potential hazards like pedestrians, cyclists, and other cars. It is a busy place that naturally requires a lot of visual scanning. They even threw in 6 hazardous events, like a pedestrian stepping out from an alley or a car about to turn across their path, to make things more realistic. But they were careful to really focus the analysis on the moments between these events so they could study the normal driving behavior. The eye tracker was the star player here. It mapped where people looked. They focused on areas like the road center, the left side of the road, the right side of the road, and even the human-machine interface, which is basically the car's dashboard display. They measured how much time people spent looking at each area and how long their glances lasted. So, what did they find? When drivers were just using the PAD system without any extra mental task, they actually looked around more. They spent more time looking at the left and right sides of the road, the periphery of the driving environment, and less time fixated on just the dashboard. This suggests that when the car is handling the driving, our brains might have a little more capacity to explore the surroundings, perhaps looking for potential hazards they might otherwise miss when they're focused solely on driving. Now, here is the big eye-opening finding. When cognitive load was high, meaning they were doing that two-back task, drivers, whether in manual or PAD, narrowed their focus. They spent way more time looking directly ahead at the road center and significantly less time glancing to the sides or mirrors. It was like their visual field just shrunk, their eyes were locked forward. This happened no matter if they were driving manually or if the PAD system was on. They also asked the drivers how hard they felt the task was, and unsurprisingly, the two-back task made them feel much more mentally taxed. This confirms that the cognitive load was effective. Let's break down the core findings. First, when the PAD system was active and drivers weren't doing anything else mentally demanding, they actually looked around more at the environment. This is good news, as it suggests they weren't just zoning out, they were using that freed up mental energy to scan more broadly. However, the moment you introduce a mentally demanding task like a complex conversation or a brain teaser, that all changes. This restriction of visual search under cognitive load is the key takeaway for both manual and automated driving. It is like your brain says, okay, I am overloaded. I need to focus on the most critical information, which is right in front of me. This means that even if the car is driving, if your mind is elsewhere and you are trying to tackle something cognitively demanding, you are less likely to spot something happening on the side of the road, like a pedestrian or a cyclist. This is true for both manual driving and when you are using PAD. So, the excitement around PAD potentially making things safer by allowing drivers to scan more is tempered by the reality of how our brains work. When we're mentally taxed, we revert to a more focused, less peripherally aware state. This is a crucial insight because it means that simply having PAD isn't a magic bullet for safety if drivers are simultaneously engaging in cognitively demanding activities. Now, what about the limitations? 8 minutes is not a very long time to get a full picture of how drivers behave. In real life, people drive for much longer. We'd want to see if this effect changes over longer periods. Also, this was a driving simulator. Simulators are great for controlled research, but they don't fully replicate the real world. The feeling of risk might be lower, which could affect how much people really engage with the driving task. In the real world, drivers might be more cautious, or conversely, more complacent. So, what does this all mean for us? It means that even with partially automated driving, our brains are still our primary safety feature, and they have limits. When our minds are busy with other demanding tasks, our visual attention narrows, and we miss what is happening in the periphery. This is critical for understanding safety in the age of automation. It highlights that simply turning on the automation doesn't mean you can mentally check out, especially if you are doing something that requires a lot of brain power. The researchers are calling for more awareness and development of countermeasures for these cognitively demanding distractions. It is not just about keeping eyes on the road, but also about the mental state of the driver. Maybe cars of the future will have systems that can detect when you are too mentally occupied, even if your eyes are technically on the road, and give you a gentle nudge to refocus. This research is a really important step in understanding how we interact with increasingly complex car technology. It tells us that while automation can help, it doesn't exempt us from the fundamental limitations of human attention and cognition. The story here is that our brains, when overloaded, become tunnel vision. And that is a risk factor whether we're driving ourselves or letting the car take the wheel. What do you think about these findings? Have you noticed yourself zoning out or becoming too focused ahead when using any kind of driver assistance? Let me know in the comments below. If you found this breakdown helpful, please give it a thumbs up, subscribe to RUBIN'S Mind Lab for more science explained, and hit that notification bell so you don't miss our next video. Thanks for watching and stay curious.